Thank you all for coming to our presentation of National Parkfinder. My name is Sarah Osgood, and my pronouns are she, her.
I'm JP Carey, and my pronouns are he, him.
And I'm Bailey Dunning. My pronouns are she, her. We are all in Mod 4 from the 2008 front-end cohort.
This project was born out of a discovery of the National Park Service's API. We were inspired by the untapped potential of data it provided. As far as we know, there is not an app like this in existence for U.S. national parks.
The National Park Service website does not have the easiest user experience, and it lacks personalization we think is important in order to learn about and discover U.S. national parks. We wanted to create an experience where users could not just see park pages, but save them as visited and bucket list items in a collection.
We're excited to share this application with you because we're all passionate about the outdoors. Our goal was to fuse our past experience with what we have been learning at Turing. This project required us to implement a stretch technology that is not part of the Turing curriculum. We chose TypeScript because of its popularity in the tech industry. We found there are a lot of benefits to utilizing TypeScript in a React application, such as improved maintainability, code consistency, and static type checking.
As Bailey noted, we used React as the framework of our project. Our project was made with all functional components using hooks. Although learning React is a required part of the Turing curriculum, we have all found that it makes coding much more fun, as well as more efficient, and allows us to build more complex and interactive applications.
Following test-driven development principles, our tests were written in JavaScript with React testing library and Jest. The page styling was structured using SCSS and built using Node.js, Travis CI, and deployed with Heroku. We also recently implemented local storage to allow the user's saved parks to persist beyond session.
Now let's dive into the app in action. When the page first loads, one of the 63 national parks will be selected at random to present. By clicking on this button with the intertwining arrows, we can achieve the same randomization effect. As you can see, each park is displayed in this list of buttons. Upon clicking on a particular park, we make a call to the National Park Service API using its corresponding 4-letter park code, which will give us all the information we need to show. If we scroll up to our search feature, you are able to find a park a couple of different ways, searching by name or filtering by state. After noticing so many states without national parks, we decided to disable the ability to select those options. These filters work in conjunction with one another, so you are able to continue filtering by name with a state selected.
With the information about the park, it starts out with a slider of photos that you can scroll through using the arrows. These photos are taken directly from the National Park Service, the National Park Service API. And then below that is information about the park. It defaults to the about information. So there's information about each park. There's weather info and then activities that you can do at each park. There's also the location, which includes directions and an interactive map. You can zoom in or out, kind of see where the park is located. And then there's also contact information, so an address, email, and a couple of phone numbers.
Also within the park page, you'll notice that the user has the ability to add items to a bucket list. There, they may also visit that bucket list and see all of their saved bucket list parks. And in these cards, you, as the user, can click on one of these pages and go back to them through that link on the card. And returning back to the bucket list, one other feature is that you can add an item from the bucket list to the visited list directly, and that will remove the item from the bucket list, making it also appear in the visited list. Now the user also has the ability to remove an item from the visited list as well. And all of these parks are actually saved through local storage, so the data saves beyond session.
We overcame a lot of challenges while developing this application, primarily adjusting to the steep learning curve of TypeScript with no prior experience. We found using a language that doesn't exist within the Turing curriculum substantially limited our usual support network. However, through collaboration and paired programming, we were able to face each challenge one error at a time to come to a solution.
Setting up the National Park Service network requests were a challenge. The API allows limited network requests per hour, querying for parks was temperamental, and the data itself was disorganized. Upon fetching a park, the client received a got object, and we only needed about an eighth of the data for the application. Ultimately, managing these requests was a great learning experience about the request response cycle and efficiently managing data.
Finally, we simply did not have enough time compared to our passion for this project. We truly all enjoyed working on this and want to do much more than was possible within the 8 days we were allotted. We'll share more about what we hope to add and update later in the presentation.
On the bright side, we are so proud of how this application turned out. We feel that this is a product people would actually use, and since we implemented local storage, we have actually started using it ourselves.
Our biggest win is that we built this application and learned to use TypeScript all in just over a week.
On top of that, this was the first application we built entirely with React hooks and functional components. No class components were used to manage state in this application.
We have a lot of ideas for future iterations of features we hope to implement. To start, we are currently using a local data file to display all the parks in our side navigation. We built an Express server that is currently deployed with 3 endpoints: get all parks, get a unique park, and post a park review. Integrating this API will take some reworking of logic, but would ultimately provide us with a more efficient application and the ability to handle all API calls through our own server.
We think our application looks and works great on a desktop, but we would like to make it responsive and compatible for mobile and tablet devices. We also would like to add a login feature for users and include the ability for users to rate and make comments and reviews about national parks using the Express server we have started.
As mentioned, the park data fetched from the API was larger than what we needed. At the very least, we would like to make a standard way to clean that data either before or after it is fetched. After doing some research on GraphQL, we discovered querying only for the data we need before it reaches the client could be a scalable solution.